Hey, Calculus crew. I'm not going to be in today, so that's why I'm making a video. And this was not the original lesson we were going to do, but I think we already have some experience because of the last quiz, so I felt like this would probably be a really good one to do already. And if you're looking for me, I'm downstairs with Miss Cash. Well, not with Cash, but in Cash's office, that little room right before you hit Cash. But yeah, today I don't think you'll need any assistance. It's pretty straightforward. So make sure you read these notes here. So we're gonna be talking about the antiderivative, guys. So we're gonna be doing about this specifically, and it means let's see, f of x, the general antiderivative or indefinite integral. So we call it indefinite integral because this elongated s doesn't have any numbers on the lower or upper. So that's all this means is antiderivative. Let's see what it says here. The function f of x appearing on the integral sign is called the integrand. The symbol dx is a differentiable. It is part of the integral notation and serves to indicate the independent variable. The constant c is called the constant of integration. And later on, when we get more advanced, guys, we will talk about what this means in terms of geometry. But right now, in terms of what it means, so in case you don't understand what any of this right here means, it literally just means this. Integral symbol, f prime of x dx equals f of x plus c. So you can see it's just the antiderivative. I have a derivative in here, and then all of a sudden I have the regular function. So if I have my function in here and I take the derivative, I should be able to get this right here. So you must have that elongated x, and you must have that differentiable dx. And of course, at the moment, all that tells you is dx. It tells you what's the independent variable, as it tells you up here, guys. No big deal. It's pretty straightforward. It's not going to be anything crazy. So this rule you already know. It's pretty much the same as your derivative rule, but you're going backwards. So x to the power n, if you have any polynomial, you take that polynomial, you add 1, and you divide by that expression, and then you just put a plus c. And you can do that for all of them. Now this we haven't talked about, guys. We're actually going to do that today in today's lesson. You'll know it tomorrow. So tomorrow we'll talk about what the derivative of our early transcendental function is, which is what that is right there. And then these rules here, it's the same as your limit rules, guys. It's the same as your limit rules. So what it's saying here is if I have the integral of x squared plus 2x dx, I can split that up into integral of x squared plus the integral of 2x. That's all it's saying. See? And if I have a constant, I can pull it out just like limits. So if I have an integral of 5x squared, you can if you want. With this one, you probably wouldn't, but you can if you want do that. So yeah, and of course that will help out with more advanced functions when we get there. All right, so let's see, guys. Hopefully all that made sense, and let's get right into it. So it says, let's see if we can apply this. I don't see. Oh, hold on. Let me make sure. Oh man, I wrote some functions here that have ln on them. That's okay. We'll skip this one for now. Let's see. Do we have any more out of here? Okay. All right. So here we go. So the first thing I see, evaluate this function, 7x to the 4th plus 4 squared of x, so that's 1 over x cubed. Make sure that we don't have 1 over x because we don't know that at the moment. So I'm going to rewrite it. Integral 7x to the 4th plus 4x to the half plus x to the negative 3. So there it is. I rewrote it, guys. And now I'm going to put an equal sign. I'm going to write what the antiderivative of that is. So let's see. What's the antiderivative? This is the polynomial. I'm going to add 1 to the exponent and divide by that number. 7x to the 5th divided by 5 plus, add 1 to this expression right there, guys. 4x to the 3 halves divided by 3 halves, which is the same thing as multiplying by 2/3. And what did I just say? I'm dividing by 3 halves, which is the same thing as multiplying by 2/3. Keep, change, flip. So hopefully no one got tricked there, guys. Plus, I'm adding 1 to this exponent, x to the negative 2 divided by negative 2. Which I guess you could say is the same thing as multiplying by negative half, right? And then put plus c. All right, let's make it pretty, guys. So let's see, 7/5 x to the 5th. You can put the x on the top if you want. 2 times 4 is 8. So I'm going to write 8 over 3 x to the 3 halves. Let's see. Minus 1 over 2x squared plus c. There it is, guys. I don't see any mistakes anywhere. I think we're good. All right, let's keep going. We're going to skip this one momentarily because I see an ln with the 5 over x. Let's see. Example 3. Find f given that f prime of x equals tan cosine x and f of 0 equals 3. You don't have to do the integral symbol, guys. This is just like what we did last week. So if you want, you can just write f prime tan cosine x. And I'm literally just going to go antiderivative of this, right? So I'm going to write f of x. Oops, there's no prime there. F of x equals, well, the only way you can get tan cosine x is if you have tan sine x. See, the derivative of tan sine x is tan cosine x. And then you're going to write plus c. And then they tell you f of 0 equals 3. So f of 0 equals 3. So let's see. 3 equals tan sine 0 plus c. And a little bit of pre-calc, guys, not extreme. Sine 0 is 0, so that means 3 equals c. Now once I know what that is, I can just plug that in right there. So my function is literally just tan sine x plus 3. What do you guys think? Not that bad, right? All right. They give you some antiderivatives here, some basic ones. Antiderivative of sine is negative cosine. If you want to think about it, like, just make sure, look, watch. What's the derivative of negative cosine? Well, negative sine, because the derivative of cosine is negative sine. Okay, I said that too quick. What's the derivative of negative cosine? Positive sine, because it's like you have a negative, and then the derivative of cosine is negative sine, see? And negative times a negative is a positive. So there it is. So antiderivative of sine is negative cosine. Antiderivative of secant squared is tan, and that's basic because the derivative of tan is secant squared, see? Secant x tan x, the antiderivative of secant x tan x is secant x because the derivative of secant x is secant x tan x. Look, the derivative of sine is cosine. The derivative of negative cotangent is positive cosecant squared. Because if you take away the negative, the derivative of cotangent is a negative cosecant squared. So hopefully that made sense. Same thing with this. If you were to take away that negative, the derivative of cosecant x is a negative cosecant x cotangent x. So if you were to see a negative in the inside like that, then the antiderivative would just be cosecant x. But we don't. So there it is. So hopefully all that made sense, guys. And then we have here, while the antiderivative of basic trig integrals is straightforward, don't forget about the chain rule deal. Only going backwards. Let's look back at one in action. This tends to be the most famous one, guys. So notice there's a pi in there. So when you're doing your f of x, so let's see, antiderivative of sine, we said was cosine. See? So antiderivative of sine, where are you? Antiderivative of sine, we said was a negative cosine. So I'm going to write negative cosine, and I got to keep the argument, pi x plus c. Okay, now let's check it before we continue. If I were to take notice I left some space, so obviously we're going to put something here. If I were to take the derivative of this guy, cosine pi x, I would have sine pi x, negative in the front. Well, I already have a negative here, so negative times a negative is a positive. And then you got to take the derivative of pi x, which is pi. But I don't have a pi. So how do I guarantee that pi cancels out? 1 over pi. Because you had a pi in the front, guys. Pi times 1 over pi is going to be 1. So Travis, I don't understand. You just lost me. Okay, let's take the derivative of this. F prime of x. The derivative of cosine is negative sine, but I already have a negative there. So that means it's going to turn to a positive. So 1 over pi sine pi x, and then chain rule, times the derivative of pi x times pi. And then the derivative of any constant is 0, so there it is. Travis, that's not the same. Yes, it is. 1 over pi and pi cancel each other out. And notice you just have sine pi x, which is what they gave me. So hopefully that made sense. See? So that's why we have this 1 over pi term. And if you don't want to memorize that, guys, then you can always just memorize this. You can just go ahead and do this. I'm not a big fan of it, but I'll go ahead and write it for you guys. Antiderivative of sine some constant k x dx is always going to be always negative 1 over k cosine kx plus c. So there it is, if you want to be a robot, but please do not be a robot, guys. Make sure you understand why that is. It's because of chain rule. Alright, we're not done yet. We need to figure out this. So we have f of 2 equals 2, so let's plug that in. So let's see, f of 2 equals 2, so I'm going to write 2 equals negative 1 over pi. I'm looking at this guy right here. Cosine of 2 pi plus c. 2 equals negative 1 over pi. Cosine of 2 pi, guys. Cosine of 2 pi is 1. So 1 times anything is itself. So I'm going to have that plus c. And I'm going to move that to the other side. So 2 plus 1 over pi equals c. And now I'm getting ready to plug that back in. So your function is a negative 1 over pi cosine pi x plus 2 plus 1 over pi. And it works. If you type in a 2 in there, you can see that you're going to get a negative 1 over pi. So the negative 1 over pi and the 1 pi cancel out, and you'll just get 2. So it works, guys. Alright, we're going to skip this one because we haven't done inverse trig. That's what this is, really. Maybe you'll recognize it from pre-cal. No, maybe not. This is, antiderivative of that is arc sine. So don't worry, we'll talk about it when we get there, guys. We're just worried about the polynomials right now. So this is coming from UH quiz, and it's quiz 25, if I remember correctly. There's still some questions that we haven't, there's probably 2 of them in there, or 3 of them that we haven't mastered. It's the hyperbolic ones and the inverse trig. But right now you can probably score an 80 already. But let's just do this one here real quick. So they want you to find the original, and they give you f prime prime, f prime, and f1. Well, and they give you f prime prime x, and they give you f prime of 1 and f of 1. So here we go, guys. I'm going to take the antiderivative. So the antiderivative of f prime prime is just f prime. So 2x cubed over 3 minus x squared over 2. All I'm doing is adding, using that polynomial rule, adding 1 and dividing by that number, plus c. Alright, they tell me that f of 1 is 7/6. So, f prime of 1, sorry. So that's what I'm going to do. I'm going to write 7/6 equals 2 over 3 times 1 to the 3rd power minus 1 squared over 2 plus c. So let's see, 7/6 equals 2/3 minus a half. I'm going to do common denominator. 7/6 equals, I'm going to multiply this one, the 2/3, by 3 over 3. Oops, no, by 2 over 2. Sorry about that, guys. I'll multiply this one by 3 over 3. So we're going to have, let's see, 4/6 minus 3/6. Oh, no, don't forget we still have a plus c here. And then 7/6 equals 4/6 minus 3/6 is 1/6 plus c. So I'm just going to subtract the 1/6. So 7 minus 1 is 5. 7 minus 1 is 5. 7 minus 1 is 6. And 6 over 6 is 1. So c is 1. So now that I know that, I'm going to plug it back in right here, guys. So let's see if I can write it right here in this little corner. F prime of x is equal to 2/3 x cubed minus x squared over 2 plus 1. I'm going to do one more antiderivative. So here it is, f of x equals, and I'm going to write 2 over well, I guess 2x to the 4th over 3 times 4. Yes, once you're advanced, you can go ahead and just write 12, but I wanted to show you guys. Minus x to the 3rd over, I still have that 2 in the bottom, 2 times 3 plus x plus c. Okay, so here we go. F of x equals 2 over 12, which reduces to x to the 4th over 6. I hope no one's lost right now. You could also say 2 goes into 4 twice, and then 2 times 3 is 6. Minus x cubed over 6 plus x plus c. Again, they told me that f of 1 is equal to 2. So I'm going to write f of 1 equals 2. So 2 equals 1 to the 4th over 6 minus 1 to the 3rd over 6 plus 1 plus c. So I'm going to write it right here because it looks like I have more space there. 2 equals 1/6 minus 1/6. So it looks like they're being nice to me there. Plus 1 plus c. The 1/6 is 0 out. Minus 1 minus 1. 1 equals c. So finally, my function is, let's see, what's my function? 1/6 x to the 4th minus 1/6 x to the 3rd. You can put the x to the 4th and x to the 3rd in the top in the numerator. It is in the top, but I just like to put it on the side there. Plus x plus 1. It was kind of tough, a little bit, not too extreme. 1/6 x to the 4th minus 1/6 x to the 3rd plus x plus 1. Do you guys see it? Oh, thank you guys. All right, that's about as hard as it gets. That's not going to be too much tougher. And then these questions, which you guys are already pretty good at, I think, because we just finished the rates quiz, and they're pretty straightforward from physics. It says a car traveling with a velocity of 24 meters per second begins to slow down at time t equals 0 with a constant deceleration of a equals -6 meters per second per second. Find the velocity v of t at time t. Okay, so they tell me what the velocity is at time 0, guys. So velocity at 0 is 24 meters per second. So here we go. Acceleration at any time is going to equal -6. And if you want to put your units, you can. And I know that velocity is antiderivative of acceleration. So I'm going to write v of t is equal to -6t plus c. Now look what they told me. If you want, you can already make your C24, but I want to show all my steps. So v of z equals 24. So 24 equals -6 times 0 plus c. So that means that c has to equal 24. Now that I know that, here's my velocity equation. V of t equals, let's see, -6t plus 24. And if you want to put units on the side, you can put meters per second. And this will tell you your velocity at any moment t. So now hopefully you guys are seeing that you can do physics problems super fast, right? If it's questions like these, right? All right, find the distance traveled at the moment the car comes to a halt. Find the distance traveled at the moment the car comes to a halt. I think I might have typed it wrong. Find the car traveling velocity 24. Okay. Find the distance traveled from t equals 0 until. Okay. Find the distance traveled at the moment. Okay. I think I should have written it. Find the distance traveled from t equals 0 to the moment the car comes to a halt. So that's an interval. So I got to find the time. Find when velocity equals 0. So I might have written it wrong, guys. It's okay. No big deal. I'll look back. I'm pretty sure. Did I make that question up? Maybe. All right. So here we go. I'm going to go ahead and set my velocity equal to 0. V of t equals -6t plus 24 equals 0. Why am I doing that? Because this is when you're stopped. When stopped. I should have put in here that I was braking. Well, it's understood, right? That's why my deceleration was that. It's not a constant negative 6 meters per second squared, like after I'm stopped and I'm going to start going in reverse. That's just, I slammed on the brakes and I was decelerating at 6 meters per second per second. So anyways, negative 6t equals negative 24, divided by negative 6, divided by negative 6. T equals, what's that, 4? And of course, 4 positive seconds, right? 6, 12, yeah. So now that I know that it stops at t equals 4, I'm going to take the antiderivative of this, because I know that at the moment that I slammed on those brakes, my initial position was 0. So I know that my c is 0 at t equals 0. So here we go. My velocity was negative 6t plus 24. So my position equation is going to be negative 6t squared over 2 plus 24t plus c. But remember, we already know this. So this can just go away. So here's my position equation, guys. Negative 3t squared plus 24t. So how far did I travel until I came to a halt? It took me 4 seconds. In those 4 seconds, how far did I travel? Well, here it is. X of 4 equals negative 3 times 4 squared plus 24 times 4. So let's see, negative 3 times 16 plus, let's see, 25 times 4 is 100. So 24 times 4 must be 96. Let's see, 16, 32, 32, 42, 54, 5, 6, 7, 48. 48. So I'm going to have negative 48 plus 96, which I believe is 48. 48 and 48, 8, 16, yeah. So I traveled 48 meters before you came to a halt. Pretty cool, huh? All right, guys. We have a very simple antiderivative for you on delta. I didn't put anything hard. All the questions on delta are just polynomials. You can do them all with polynomials. I think the hardest one will probably be something like, let me see, do I give any examples in here? Okay, the hardest one will probably be something like, I'm gonna make it up. So the hardest one will probably be something like this, integral, and I probably have something like 3x squared plus 5x plus, no, that's enough. 3x squared plus 5x over x. And then at first glance, you're like, I don't know how to do that. Well, yeah, you do. What you're going to do is you take that 3x squared plus 5x over x and you put them into separate terms like so. So then one of these x's cancels out and you get 3x, and then one of these x's cancel out and you get 5. So then this turns into integral of 3x plus 5. And that you can do, guys. 3x squared over 2 plus 5x plus c. So there it is. So I think you guys can do that. Nothing crazy. If you guys need me, guys, I'm downstairs in Miss Cash's office, or right next door to Miss Cash's office. And that's it, guys. Disregard this time, 5:38 a.m. You know me, I'm hardcore math life. But don't be up super early or super late doing work. Let's see if we can just get rid of this, guys, before class is dismissed. And hook it up with a thumbs up if you enjoyed this video or you saw all the way to the end. All right, talk to you guys later, guys. Bye-bye.